All right, today is the end of the 6 weeks. We're going to continue with our conditional probability. Who are my seniors? Okay, so 1, 2, 3, 4, 5. So again, we're already missing 4, and then on top of that, it's this period that you folks are going to be called, right? Is it a video? What are y'all doing?
So I don't know. It's like this weird. It's this documentary about college and
Okay.
yeah.
Interesting.
That's all I really know about it.
Okay, then good news, we won't go the entire period since we'll have so many people out. As soon as they call for you folks, we'll just go ahead and stop. We'll see how far we can get, and then we'll just continue Monday and see what happens. Now, don't forget what's due on Monday.
The assignment.
The assignment, yay! The introduction to probability, yes. And in fact, I think you got most of it done the other day, if I remember correctly. Yes.
Have you finished the assignment?
I think they're going to call you about 45, is that right?
I'm not.
I want to say it's about halfway through the class. They'll go ahead and call for you folks. So we'll just wait. I'm going to guess it's Mr. Anderson who will come on. Yes.
So yesterday with conditional probability, is there any like vastly new information?
Not really. We kind of just barely started talking about it. We haven't really gotten into any examples yet, but I'll kind of do a quick review.
Okay.
Get to it. All right. Well, let's see what we got here. So we have this table that was on the notes from yesterday where we kind of pulled everything together. And remember, we're always going to be making connections back to sets and Venn diagrams when it comes to the probability. And we have these rules here. What did it mean by mutually exclusive? There is no intersection, they're disjoint. So if I want to know the probability of a union of two events and I know they're mutually exclusive, well then remember it was just the sum of those individual probabilities. Now if there was an overlap, if they were not mutually exclusive, then it's the same formula for that probability. We just have to subtract off the intersection because we'll be counting that twice once we go ahead and add the probability for each of those individually. And let's see here. Then we did a couple of examples. Everybody seemed to be doing all right with those. And I went ahead and introduced what we're going to come to know as conditional probability. Now, here's the notation for it. P, of course, stands for the probability, and then you've got, probably some letters or maybe in some kind of a phrase that's going to be written in there. But this vertical segment right here is going to be our keyword given. So the probability of A given B. This is the probability of A given that event B has already occurred. So we're already provided some kind of information about this scenario. Now we're trying to find the probability of this additional event. So the formula for this notation here is pretty easy. We're going to take the probability of the intersection of the two events divided by the probability of B, the second event, the one that's already occurred. So you'll notice this one, the formula is going to be very specific to how things are written. If I were to go ahead, let me erase this really quickly. If I were to go ahead and say I'm looking for the probability of B given A, this would be the probability of B intersecting A. Wouldn't that be the same as A intersecting B? Yeah, so that doesn't change, but whatever is given, that's what you're going to go ahead and divide by. So in this case, I would have to divide by the second event's probability. Okay. All right, well, let's go ahead, get right to another problem, and let's see what we got here. It says 2 dice numbered 1 to 6 are rolled onto a table. Find the probability of obtaining a sum of 5, given that the sum is 7 or less. Okay, so what's happened is we've rolled 2 dice, and we already know that we've got a sum of 7 or less. That's already occurred, but what's the probability of it being a 5? All right, now, do you guys remember what kind of diagram this is from the previous one? Lattice diagram. There you go. That's exactly right. I've already got it filled in for us here. Now, I'm going to go ahead and use this rectangle because I think in order to, for me, again, I'm a very visual person, especially when it comes to probability. It helps me to understand better if I can really kind of get an idea for what's going on. Okay, so you've got all these different combinations here that are going to give you all these different sums, of course, with the largest being 12. So what I'd like you to do is go ahead and create a Venn diagram based on this problem. Okay. Find the probability of obtaining a sum of 5. So we're talking about a sum of 5 and a sum of 7 or less. Okay, so you don't have to go ahead and create the entire lattice table again unless you want to. I'm not asking you to solve the problem just yet. I'm just saying let's go ahead and create a Venn diagram that represents what's going on here. Okay, I'll give you about, let's say 30 seconds. Okay, well, let's go ahead and start with the big picture. What's the universe going to be made of?
1 to 12.
Okay, I'm sorry?
1 to 12.
1 to 12? Okay, so everything but 1, because the universe is going to be made up of all the possible sums that we can get off the 2 dice, right?
Oh, so it'd be 2.
There you go. So all these sums right here, this is going to make up the universe. All right, now let me go ahead and highlight this, and maybe that'll make it a little easier here. Let me get the highlighter. So one of the groups is going to be a sum of 7 or less. So here are all my 7s, and then anything smaller than that's really what I want to take a look at. Okay, so how many items am I highlighting here? How many items did I highlight? I'm sorry?
23.
23? Ooh, a little off.
22.
21. There we go. It's going to be 21. But now you'll notice something. What's the other quantity we're talking about?
The sum is 5.
The sum is going to be 5, right? So do you notice anything about the ones that I highlighted? Let me go ahead and do another one right here. So here's a sum of 5, 5, 5, 5. Think about Venn diagrams, what we've talked about before.
Will the sum of 5 be one of the circles, and then the sum is 7 or less be another circle?
That's true. They're 2 different circles, but how are they interacting with each other?
So would it the sum of 5 be a subset?
Yes, because see, all those 5s are contained within that larger group, right? Okay, yes, that is exactly right. That's what I was fishing for, a subset. So let's say that this large oval here, I don't want to call it a circle because it doesn't look like much of a circle. Let's say these are all the sums. I'll just go ahead and say S7 or less. Okay, and then inside of this, we're going to end up having a, let's say, sum of 5. So I'll say S5. And unfortunately, sorry, my S's kind of look like 5. So that's not a 55, that's S5. Okay, so the smaller oval here is going to be a sum of 5, and this larger one's going to be the sum of 7 or less. Okay, now let's go ahead and talk about how many we have here. Well, we know there are 4. Okay, there are 4 sums that are going to give me 5. You said how many for 7 or less for the sum? 21. And how many are there total? 36. So how many more should be in the rectangle but not in either of these? Ooh, a little higher. Ooh.
25, 36, yeah, there should be 11 outside.
So that should be 17 instead of 21.
17? Should it be 15?
Inside 7 or less, that be 17 instead of 21 because you're counting that 4 twice.
Oh, you're right. Okay. Absolutely right. Yes. Okay. All right. And then is everybody okay with there's 15 sums left out of that? That are going to be, I would say, 8 or larger? Okay, good. Did anybody happen to get the Venn diagram created with the idea of the subset? Or was it until after I kind of started highlighting the values that made a little more sense? Okay. All right, well, now let's go ahead and put everything together. What was the key word that was going to tell me we were dealing with conditional probability? Given. Okay. So we want a sum of 5 given the sum is 7 or less. So let me go ahead and write this out. Okay. I'm not going to go ahead and use A or B. I'm actually going to go ahead and say the probability that the sum is going to be 5 given that the sum is 7 or less. And I guess if you really want to, you can go ahead and like say A is the sum of 5 and b, if you want to go ahead and do that. But okay. Now let's go ahead and apply the formula to what we have here. So this is going to equal the probability of the intersection between the two, the sum of 5, let's go ahead and say 5, intersecting the sum of 7 or less. And I'm going to divide that by, would it be the probability of the sum of 5 or the probability of the sum 7 or less?
Sum 7 or less.
There you go. Whatever is given, the event that's already occurred, that's the probability that you always divide by. The probability of the sum is 7 or less. Okay. So now, let's take about another 30 seconds. Let's see if you can go ahead and fill in. Because now that we have the Venn diagram, hopefully you're going to see what the intersection is. Okay, don't say it out loud. Let's give everybody the opportunity.
Yep, I do the ladder.
Yes, let me go ahead and scoot this back down. Let us take a look at it.
Oh, I made that.
I know, but I knew it was so good I had to use it myself. Boy, that's a good thing. Yeah.
I know, but I want to go back and...
Oh, that was Eli's joke. There you go. Now he'll be immortalized forever. Oh. Whoa. Okay. All right, and I'll go ahead and put it right here since I have the room and I got the Venn diagram showing. Okay, so let's see here. The probability I'm looking for is going to equal. Now, can anybody tell me what the intersection of the two is going to be? How many elements do they have in common? They got 4. Remember, because the sum of 5 is a subset, so that is the intersection, right? Now, 4 out of what? Now 21. Now, see, we're doing it out of the universe. So 4 out of 36 would represent the intersection of the two. Okay. Now, what's the probability if I were to just look at the lattice diagram and randomly choose a sum 7 or less?
21.
That's 21 out of 36. Is everybody okay where I got those values from? The numerator is the intersection of the two. The denominator is just the probability of a sum 7 or less. Okay, well, what happens when you divide by a fraction? You multiply by its reciprocal. So this would be 4 over 36 times 36 over 21. And you'll notice those 36 are going to cancel 4 21sts. Okay. Now, had we reduced before we went ahead and took care of the multiplication, would I still gotten the same answer? Absolutely. Okay. So 4 out of 21. In fact, does anybody want to see me reduce that and then show you that you get the same thing? No? Sure? Okay. So go ahead and take this out right here. So let's say this would be the probability of, so 436 would be 1/9 over 2136? 7/12. Okay. So now I'm going to multiply, so this would be 1/9 times 12/7. Okay. Now you could go ahead and multiply straight across, but yeah, 9 and 12, they're both divisible by 3. So you're still getting your 4 21sts. Okay. Yeah, maybe. I mean, there's definitely less step involved. Mm-hmm. All right. How we doing? Okay. Well, let's try another problem. Let's try this guy right here. Now, you'll notice I was prepared today. Not that I'm never prepared, but you know what I mean. Oh, that's a highlighter. Okay. There's a highlighter again. I'm going to move it with my mouse. There we go. Okay. And I'll just leave it there because it's pretty. All right. So here's the next example. Two events, A and B, are such that the probability of A is 0.5, the probability of B is 0.3, and the probability of the union is 0.6. Now this one's different because it's not immediately giving us the intersection. So we have to work backwards to figure out what each of these spaces are going to be. Now remember, the entire universe should be what? 100%, my probability, okay? So do you want to talk through it together, or do you want me to give you a little bit of time to try it on your own? You want to do it together? Okay, so I'll tell you what, let's set up the diagram together, and then I'll have you try the first example on your own. Peyton? Can I move what? Oh, is it bothering you? It is. It really is. There we go. Peyton, we're good? Okay. All right. Okay, so where are we going to start? Okay. So we don't know the intersection immediately. Okay. We could, like, for example, what does the union mean?
It means A plus.
That means everything added up, right, is going to be 0.6. Well, what is, for example, the probability of A?
Probability of A.
So if I know that this whole circle, let's go ahead and call this A and this B. If A is supposed to be 0.5, but all of it is 0.6, then I know that has to be 0.1. Does that make sense?
No.
Okay. Yes.
Wait, so what I did was the A was 0.4, and then the intersection was 0.1, and then B was 0.2. I just subtracted the point.
Yeah, the intersection should end up being 0.2.
But when you add them together,
Yes.
yeah, but why would the 0.2 be on the B and then the 0.1 be in the intersection?
Yeah, because then the values wouldn't add up.
Oh.
Okay. And we can also work it in the other way just to kind of confirm that we got the right answer. So what would be strictly A? 0.3. Because the union, the sum of all three, would have to be 0.6, right? Okay, so let's kind of look at that from the other side. We know that every part of both circles has to add up to 0.6. Well, last time we started with A. Well, this time, what does B's entire circle need to represent? See, it needs to be 0.3, right? But all of this is 0.6, so what's this little area here? It has to be 0.3. See, I'm still getting the exact same value. And now let's go for the intersection. If A is supposed to be 0.5, but I've already got 0.3, then 0.2 should be the intersection. Is everybody okay? Michelle, is this making more sense? All right. And what was the last one here? 0.1? Okay. And don't worry, we're going to get other opportunities to practice this. This is definitely not the only Venn diagram we're going to see. All right. So now there's something I'm missing, though. There you go. In the rectangle, but not in the circles, we've got a 0.4. Because remember, everything has to add up to 1. Okay, there you go. All right. Now, let's go ahead. Okay, so I worked the Venn diagram with you. I helped you set it up. Now, take care of A for me. The probability of A given B. So I'll go ahead and write out the formula. This is going to be the probability of A intersecting B. And what am I going to divide it by? B. Whatever is given, the second part, that's the probability that you always divide by. Okay. So let's see what you guys come up with. I don't think we're going to have much longer before they go ahead and call for the seniors. We'll kind of see. Okay. Does anybody still need a little more time? Okay. All right, well, let's go ahead and start. Now, when we have especially when we have a diagram, whether it's a tree diagram, lattice, Venn, all of these for me just really help me see what's going on. So we can immediately tell what's the intersection. It's got to be 0.2 over. What was the probability of B? Okay, that was 0.3. Now remember, 0.1 was strictly B, but this 0.2 still belongs to that. Okay. Now, if you were to go ahead and put it, in the calculator, you should end up with like 0.6 repeating. Okay. But does anybody remember what can I divide a value by to move the decimal 1? I'm just kind of showing you an alternate way. Maybe you don't have a calculator. Like, wouldn't 2/10 be 0.2? Okay. And then 0.3 would be 3/10. I'm just kind of showing you another way. Now, multiply by that. So this would be 2/10 times 10/3. So you're still getting 2/3. Okay. But just in case you didn't have a calculator, Okay. But yeah, you could just take 0.2 and divide it by 0.3 and get your 0.67 or 67%.
Or and 67 since also 2/3.
Well, yes. Mm-hmm. Yes. Yeah. Yeah, just the way I did. Exactly right. Oh, and remember yesterday I warned you, it did get 2/10 in here. The joke comes back. It came full circle. Okay. Ah. Yes. Sometimes as I'm making the lesson, I kind of think this would be a great place to put a joke in. But a lot of other times I'll just be looking at this and be like, hey, that'll probably be a really stupid thing to say. I'm going to say it. And it works out nicely. You can tell by looking at Michelle's face, man. She's just dying laughing. All right. Oh, yes. Are there any avid students who are going to this as well? If you're an avid student, they said you were going to be given a blue ticket. Does that apply to anybody in here? No, not unless you got a blue ticket. Sorry. All right. Well, we will go ahead and stop there because we're losing quite a bit of the class. All right. So we'll just continue on Monday. All right. Thank you, guys.